Welcome to Exploring Space and Time. When you think about the universe, do you think about its size? When you look at the night sky, you see only a small fraction of the cosmos. Every star visible to the naked eye, about 4,000 of them, is located within a tiny portion of our own galaxy. On a human scale, crossing an ocean takes weeks by ship. Even our fastest aircraft need a full day to reach the globe's opposite side. But those measurements fail once we leave the atmosphere. If you were to drive a car at highway speeds to Pluto, you would spend roughly 6,000 years behind the wheel before reaching the edge of our solar system. Miles and kilometers are too small to describe these gaps. Astronomy requires a measurement based on the fastest thing in the universe. Light travels at a constant 186,000 miles every second. We use the distance light covers in a single year, the light year, as our new standard ruler. Even at that speed, light takes 8 minutes to travel from the surface of the Sun to Earth. The nearest star outside our solar system, Proxima Centauri, is 4 light-years away. If that star were to vanish, the signal would take 4 years to reach our telescopes. Because light itself takes years to cross the gap to our closest neighbor, every solar system remains physically disconnected from the rest of the galaxy. Zoom out further, and you find the Milky Way. Our home galaxy contains hundreds of billions of stars and measures 100,000 light-years across. To see that scale, imagine our entire solar system was shrunk to the size of a coin. On that scale, the Milky Way would be as wide as the North American continent. Looking further into space also means looking further back in time. Light from the most distant objects has been traveling since the early history of the universe. Deep field images reveal our galaxy is just one of many. Astronomers estimate up to 2 trillion other galaxies fill the observable sky. Our entire galaxy, with all its billions of stars, is just a single point in an ancient, interconnected web of other star systems. The limit of what we can physically see is called the observable universe, which currently measures 93 billion light-years in diameter. This creates a paradox. The universe is only 13.8 billion years old, yet we are seeing things located 46 billion light-years away in every direction. This is possible because of the metric expansion of space. While light travels towards Earth, the space it traverses actively stretches. Objects that emitted light 13.8 billion years ago are pushed further away, stretching their light waves into a redshift. That 93 billion light-year diameter measures the total growth of the fabric of spacetime since the moment the expansion began. The observable universe is not a physical wall. It is a horizon created by our location and the finite speed of light. An observer in a distant galaxy would see a different spherical bubble of space, overlapping with ours, but centered on their own location. Beyond these horizons, the universe likely continues. Many cosmological models suggest it may be infinite in extent. Confronting a void without a measurable end can make the scale of human life feel difficult to grasp. However, the billions of years required for the universe to reach this size provided the time necessary for the chemistry of life to develop. The carbon, iron, and oxygen that make up our bodies were forged inside the hearts of early stars. These elements were only released into deep space after those stars aged and exploded over billions of years. While there are septillions of stars across trillions of galaxies, all known history and life are concentrated on our single planet. By looking back at these ancient horizons, the same atoms forged in those early stars have evolved the capacity to map their own origin. Take a look at our video on black holes and learn about Hawking radiation. Which cosmic fact amazed you the most? Let us know in the comments below and subscribe to Beyond Earth for more explorations.